Okay, so in this video, I'm going to go over the solutions to review sheet number 2 and kind of wrapping up some of the algebra that we need for Intro to Calc, and this is assignment number 15. All right, so the first one is we're just going to graph our basic function, and we should know that our very first step is to identify the vertex, which is 0, 1. This is one of those that sometimes tricks you a little bit when you have the negative in the middle, but you can rewrite it as such. So my vertex is 0, 1. There it is. And then I cannot pick most people like making a table. So I can't pick a negative number because I cannot take the square root of a negative. But I can pick 1, and the square root of 1 is 1, and 1 minus 3 is -2. So over 1 down 2. And I'll pick one more number like 4. The square root of 4 is 2 times -3 is -6, and 1 minus 6 is -5. So 1, 2, 3, 4, down 1, 2, 3, 4, 5. So I started here, and I'm going to connect it to where I'm going. And why is this graph flipped upside down? Is because the leading coefficient is negative, so it flips the graph upside down. In this one here, I'm still going to pick 1 to get that started, and 1 squared is 1, minus 2 is -1. 0 is also less than 1, and 0 squared is 0, minus 2 is -2. And then I'll pick -1. -1 squared is 1, minus 2 is -1. So I think I'm just going to connect those now then. So it's 1, -1. That gets an open circle because it's not equal to there. 0, -2, and then -1, -1. This is where I started. This is where I'm going towards, and it's concave up because of the positive x squared. Here, I'll put in 1, get 2, pick 2 because that's bigger than 1, get 4. So go over 1 up 2. It's a closed circle because of the equal to part. And then 2, 4 over 2 up 2, 3, 4. And there is my graph. So kind of a big jump there in that discontinuity. In number 2, we want the equation of a line perpendicular to the one that's given. So I need a slope and a point. So for any line, I need a slope and a point. And the point I already have is 3 minus 2. In order to get the slope, I need to solve this equation for y. So I'll do that by subtracting 3x and dividing by -2. And when I do that, 4 divided by -2 is -2, and -3 over -2 is +3/2. The slope of this line, though, is 3/2. So to be perpendicular, I need its negative reciprocal, which is -2/3. So I'm going to set this up as y minus the -2 over x minus 3 equals -2/3. So when I cross multiply, I'll get 3 times y plus 2 equals -2 times x minus 3. Distribute. And then I'm going to solve for y by subtracting 6. When I do that, those 6's will add to 0. And then divide by 3. And there's my line. In number 3, just a pile of equations to solve. I want this piece alone. I'm going to add 6 to each side, get 10. Divide by 2 to get 5. And x will equal plus or minus 5. Over here, don't overcomplicate this. You can get the x alone by adding 6 to both sides to get 9, and then dividing by 3 to get 3, because 9 divided by 3 is 3. You undo the square by plus or minus the square root, and then add the 2 over. And there are my solutions. Irrational solutions occurring in conjugate pairs, by the way. Here, don't try anything too fancy with this. Just try reverse FOIL. So factors of 7x squared are 7x and x. And I'm going to try 2 and 1 here, minus here, positive here. I know that 7x times 1 is 7x squared, and 1 times minus 2 is minus 2. But I need to check that the outer, negative 14x, with the inner, plus 1x, does give me negative 13x. And it does. So then I'll set each of these factors equal to 0, subtract the 1, divide by 7. And over here, I'll just add the 2. Over here, I'm going to add 8 to get x cubed equals 8. And you undo a cube, guys, by the cube root. The cube root of 8 is 2. Okay, down here are just some more factoring questions, or I'm sorry, operations on functions. So here, I'm going to do f at 2 plus h. So I'm going to replace x with 2 plus h. We did these a lot, but we may just have something added. So this FOILed out is 2 plus h times 2 plus h. So that FOILed is 4, and 2h and 2h makes 4h, plus h times h is h squared. So I'm going to distribute that 3 through there and get 12 plus 12h plus 3h squared minus 4 minus 2h plus 4. And then now I need this f at 2. I'm just going to replace x with 2. 2 squared is 4 times 3 is 12 minus 4 plus 4. And well, 12 minus 4 is 8 plus 4 is 12. So this value is minus 12. The 12s add to 0 now. The 4s add to 0. And what's left is 12h plus 3h squared minus 2h. Here, I think we're pretty good with this one. I'm just going to replace negative 1 into g. So what does that give me? Hopefully something not. So that's negative 1 squared is 1 times 7 is 7 plus 2 minus 4. So 7 plus 2 is 9 minus 4 is 5. And then now I got to put 5 into f. So I think we're okay with that, just function composition. 5 squared is 25 times 3 is 75 minus 10 plus 4. And that's 65 plus 4 gives us there 69. Down here, what does this mean to do? This means to do 2 times g of x minus 3 times f of x. So I'm just going to do 2 times g. I guess I'll write that over then to take my time. And then minus 3 times f. Distribute, guys. That's all you got to do is distribute. Minus 14x squared minus 4x minus 8 minus 9x squared plus 6x minus 12. And this here gives me what's 14 minus the 9 gives me the 5x squared. What else is there? This and this makes plus 2x, and this makes the minus 20. And what does this notation mean? It means f at negative 2 minus g at negative 2. So what is f at negative 2 equal to? Just replace x there with negative 2. Negative 2 squared is 4 times 3 is 12 plus negative 2 times negative 2 is 4 plus 4. And 8 plus 12 is 20. And g at negative 2, do I have enough room here? G at negative 2 is 7 times negative 2 squared minus 2 times negative 2 minus 4, that is. So why am I not writing that right? Negative 2 squared is 4 times 7 is 28 plus 4 minus 4. Because that gives you plus 4. And that's 28. So it's 20 minus 28, which is minus 8. So all you just simply do is just do the two functions at -2 and subtract your answers. Factoring completely, this is a difference of two cubes. I'll take the cube roots of both, which are 3x and 2y respectively. Square the 3x, get 9x squared. Squeeze those together, but change the sign. And square the last term, which is 4y squared. Here, I will take out an x. And that's what's left. But that's further factorable by a difference of two cubes. And that's where I take the cube root of x cubed, which is x. The cube root of 1,000 is 10. Square the x to get x squared. Multiply these to change the sign, and square the last, which is 100. In part C, I'm going to take out an x. And I'm going to try and factor that further into 3x and x and 2 and 1, but they're both negatives. Because when I have a negative in the middle, positive on the end, both binomials are negative. And I know that 3x times x is 3x squared. I know that -1 times -2 is +2. But the outer is -6x, and the inner is -1x, which gives me -7x, so I have the right combination. Then in part D, just take out an x, and that further factors into x minus 3 and x plus 3, because that's a difference of two squares. I just want to see how much is left. In the next part, this is going to be the 0 is x equals 0, x equals 2, x equals -3. Because of the even power, it's going to bounce off the x-axis, and here it's going to cross and cross because of those odd powers. Over here, x equals 3 and x equals -2. -2 comes from the even power, so it's going to bounce off the x-axis, and here it's going to cross. Now to determine the end behavior. In order to determine the end behavior in number 7a, you need to distribute so you can recognize the highest exponent. And that term is -2x cubed. It's an odd degree, leading coefficient's negative, so that's the end behavior. So as x goes off to infinity, the f of x's are going off to -infinity. And as the x's go off to -infinity, the f of x's go off to infinity. Remember, end behavior requires both x is going to infinity and -infinity. When this power is odd, these better be opposites. Here, with the rational one, you have to take the highest exponent on top, which is x cubed, and divide it by the highest exponent in the bottom, which is -x to the first. But that will reduce to give you -x squared. So the end behavior will be like a -x squared. In even degree, the beginning and the end are in the same direction, but the leading coefficient being negative will flip it upside down. So x going to infinity, the f of x's will go off to -infinity, as well as the x's going towards -infinity. Those will also go off to -infinity. They have to be the same when that power is even. Okay, so now in this last part here, or next to the last part, we're just going to solve these inequalities. So the first part is set to 0. I'm going to factor, well, not into that. How about x minus 4? And x minus 4. Let's try that again. So, so this is going to be x minus 4 times x plus 3. My critical points are 4 and -3. So everything's an open circle because it's not equal to. I'll pick -10 as a test point. Put that in for x. So that's -14 times a -7 and a negative times a negative is a positive. If I pick, say, 0 for x, because that's in between -3 and 4, 0 minus 4 is -4 times a +3 is a -12. And if I pick, say, 10, 10 in for x, guys, 10 minus 4 is a positive, and 10 plus 3 is a positive, times a positive is a positive. Now, where are we greater than 0? Where the number line is positive. And where's that happening from? Negative infinity to -3, and then from 4 to infinity. So again, we had that question is, well, where do we shade? Well, when we're talking greater than 0, wherever the number line is positive. If you're less than 0, it's where the number line is negative. In part B, I'm tasked to subtract x from both sides. I'm going to factor out an x, and what's left is 2x minus 1. There's only a GCF in this one. So the critical points are 0 and 1/2. And sometimes the question came up, well, how do you get this 0? Just set it equal to 0. Add 1 and divide by 2. Both of these will be a closed circle because it's equal to. If I pick, say, -10, put that in for x, I would get a -10 times a -21. A negative times a negative is a positive. Here, between 0 and 1/2 is like a quarter. That's in between there. So a quarter in for here is 1/4. 2 times a quarter is a half. Minus 1 is a -1/2. So a positive times a negative is a negative. And if I pick, say, here 10, I'll get 10 times a +19 is a positive. Well, this one again was where it was greater than or equal to 0, and that's where the number line is positive. And where's that happening from? Negative infinity to 0 bracket, and then from 1/2 bracket to infinity. Remember, it gets the bracket because of the equal to part. Are our answers reasonably correct in reflecting? Yes, all signs are alternating because these multiplicities are odd in both cases. So all signs should alternate from one critical point to the other. In part C down here, we've got 3 critical points. One, just got to put them in the right order. -3 and -2. Everything is an open circle because there's no equal to part. All right, so if I pick, say, -10, which is to the left of -3, I'll get -10 minus 1 times -10 plus 3 over -10 plus 2 squared. And guys, that's going to be a -11 times a -7 is a positive divided by that positive in the bottom because anything squared is a positive. Now, if I pick -2.5, so I got to put that in for x. -2.5 minus 1 is negative. -2.5 plus 3 is a positive. So a negative times a positive is a negative over a positive is a negative. If I pick 0, that's in between -2 and 1, I'll get 0 minus 1 times 0 plus 3 over 0 plus 2 squared. -1 times a +3 is a negative. And then last, guys, if I pick 10, I'll get a +9 times a +13 over a positive, which is a positive. So in the reflection part, I would not expect a sign change at -2 because that -2 came from that even power. Once again, where am I greater than 0 is where the number line is positive, from -infinity to -3 and from 1 to infinity. And then over here in part D, I need to take out an x, and what's left is x squared minus 6x minus 8. factor that further into x minus 4 and x minus 2. Your critical points are 0, 4, and 2. Build a number line, 0, 2, and 4. Everything is going to have a closed circle because of the equal to on the inequality. If I pick negative 10, I'll get a negative 10 times a negative 14 times a negative 12. An odd number of negatives multiplied is a negative. If I pick 1, I'll get a positive 1 times 1 minus 4 is negative 3, and 1 minus 2 is a negative 1, and a negative times a negative is a positive. If I pick 3, put that in for x, I'll get 3 times 3 minus 4 times 3 minus 2, and that result is a negative. And if I pick, say, 10, put that in for x and putting it here for x, and then that's clearly a positive. All signs are alternating. These are all odd powers, so they should alternate. Where am I less than or equal to 0? Where the number line is negative. So negative infinity to 0 bracket, and then from 2 to 4. Bracket because of the equal to. Phew. In part E, the last part, I got to set this thing to 0 by subtracting 1. But I need to get a common denominator by multiplying by x minus 2 over x minus 2. So then on top, I'm going to have 4x minus 2 minus x plus 2 over x minus 2. That's what I'm going to have on top. And then when I clean this up here, guys, I get 4x minus x is 3x only, right? And negative 2 plus 2 is 0 all over x minus 2. So cleaned up pretty nicely then. So once again, set it to 0 by subtracting 1 and multiplying top and bottom by x minus 2, and then distributing that minus sign through. My critical points are 0 and 2. The bottom critical point, which is 2, always gets an open circle because you can't divide by 0, while the numerator will be 0 because we're including 0 here. So this critical point is 0, this critical point is 2, but the bottom critical point gets the open circle. What's my test point? Negative 10. So I'll get a negative 30 over a negative 12, and a negative over a negative is a positive. Then pick 1. I'll get a positive 3 on the top, and 1 minus 2 is a negative. And a positive divided by a negative is a negative. And to the right of 2, I'll pick 10. I'll get a positive 30 over a positive 8, and what's that? Positive. Should my signs alternate? Yes, because these powers are odd. Where am I less than or equal to 0? Where the number line is negative, bracket at 0 though, parenthesis at 2. And last but not least is a graphical approach. Where are the f of x's now? Not sure if you realize this, but on this graph right here, that's the x-axis and that's the y, is the one going down. So therefore, where the f of x is greater than 0, where is the graph above the x-axis? Because it tells you right here that's the origin. So of course that's got to be where the x-axis is, and this is your y-axis. So where's the graph above the x-axis? From x equals 0 to x equals 1. Where is the function less than 0? Where's the graph below the x-axis? That's going to be from negative infinity to negative 2, and then from negative 2 to 0. And then this part here, I really wanted you to answer, where is f of x equal to 0? That's where the function hits the x-axis at negative 2, 0, and 1. If we were to be greater than or equal to, then that just means we're going to put brackets on 0 and 1 because we're including it now. So that's how we would answer that question. And that concludes the solutions to review sheet number 2 here on this sort of practice exam.